We're going to compare the differences in workflow between Onshape and FreeCAD to model this simple part, which is a bicycle seat clamp. It'll be a straightforward modeling process followed by an assembly. You might be surprised by the result. On the left, the part will be modeled with Onshape, and on the right, with FreeCAD. You can follow the video as if it were a beginner's tutorial. Before we begin the comparison, let me know in the comments which software you use and why. The video is divided into chapters, so you can go directly to the sections that interest you. We will do a quick comparison between the two software after each step, and you'll find a full summary at the end. You will also find the 3D files for the tutorial in the description. You can download them for free on my Ko-Fi page, or make a donation if you want to help the channel grow. Thank you in advance. Let's start with Onshape. The interface may differ from yours because I had to resize it to fit the screen. To create a sketch, you first need to select a plane. In our case, we choose the top plane. So, left-click on the top plane, then click on the sketch icon in the top menu. To make it easier to draw, we'll click on the word top on the navigation cube to align the view perpendicular to the sketch plane. We'll start by drawing two circles at the origin point. To do this, go to the top menu where the line icon is, then click on the small black arrow to select the circle tool. Then, left-click on the center point of the plane and move your mouse to enlarge the circle. Then, left-click to confirm the drawing, and type the dimension of the circle, which will be 39 millimeters. Repeat the same operation to create a 34 millimeter circle. We're going to draw the rear part of the clamp. To do this, go to the Sketch Geometry menu, click on the black arrow, and select the Line tool. Start with a vertical line to the left of the circle by left-clicking to begin the drawing. Then make another left-click to connect the line to the circle. Press Escape to stop using the tool. Repeat the same drawing, but this time below the axis. You can use the Symmetry tool if you want, but when it's just a few lines like this, it's sometimes faster to recreate them. Press Escape to stop using the tool. Now, we're going to apply constraints to fully define our sketch. We'll start by making the lines that touch the circle tangent to it to ensure a smooth transition between the circle and the lines. To do this, simply select the line and then the circle without holding Control. Then, go to the Constraints menu, click on the black arrow, and find the tangency constraint. Repeat the same operation for the bottom line. Next, select the two small lines on either side of the axis and apply an equality constraint by clicking on the equal icon in the Constraints menu. Now, let's apply dimension constraints. Go to the top menu and click on the Dimension tool. You can select the 2 points on either side of the line, or with just the line itself, to apply a dimension. Give a dimension of 8 millimeters. Still using the Dimension tool, give a dimension of 28 millimeters between the center of the circle and the point at the far left. To avoid multiple contours, even though Onshape can handle it, we will delete the arc of the large circle on the left so that we only have one contour. To do this, we'll use the Trim tool to remove that part of the line. Click on the Trim tool in the top menu. Then click on the part of the circle you want to remove. The sketch is now complete. We can exit it by clicking the green check mark at the top. We're now going to extrude the sketch's contour to give it volume. To do this, first select Sketch 1 in the left menu, then click on the Extrude icon in the top menu. In the menu that opens, you can leave the default settings and just change the depth to 14 millimeters. This will extrude the contour over a distance of 14 millimeters. Note that in this menu, we also have several options, such as the ability to create an extrusion that removes material. We can confirm the operation by clicking the green check mark at the top. We can hide the 3 planes by clicking on the eye icon in the left menu. We've completed the first extrusion operation. Now, let's see how this process works in FreeCAD. Before starting the modeling in FreeCAD, make sure you are in the Part Design workbench. To create a sketch, click on the sketch icon in the top menu. FreeCAD will ask you to choose a sketch plane to draw on. Select the XY plane, which corresponds to the top plane in Onshape, and left-click on it. You'll notice that, unlike Onshape, the 3D view in FreeCAD automatically aligns perpendicular to the sketch plane, allowing you to draw flat, just like on a sheet of paper. In Onshape, you have to manually adjust the view. You can change this setting in FreeCAD if you don't like it. We'll start by drawing 2 concentric circles with their center at the origin. To do this, click on the Circle tool in the top menu. Then, left-click to place the center of the circle on the origin point. You can then move your mouse to enlarge the circle or directly enter a diameter value. In our case, type 39 millimeters and press Enter to confirm. Still using the Circle tool, repeat the same operation but set the diameter to 34 millimeters. At this point, you should have two concentric circles in green. Now, we're going to draw the rear part of the clamp. To do this, we'll use the Polyline tool. Go to the top menu and select the Polyline tool. Start your drawing by snapping to the bottom left part of the circle, then draw vertical lines on either side of the red axis, and finally connect to the top left part of the circle. To stop using the tool, right-click or press Escape. We're going to make the circle tangent to the straight lines that touch it to ensure a smooth transition between the two. To do this, select the line and the circle, then click on the Tangency Constraint icon in the top menu. You can uncheck the box in the menu that opens to stop being bothered by this message. Then click OK. Repeat the same operation for the bottom line. Next, select the two small lines on the left, then click on the Equality Constraint icon in the top menu to make them the same length. All that's left is to add dimensions to fully constrain our sketch. Click on the Dimension tool in the top menu, then give a horizontal dimension of 28 millimeters between the left center point and the origin. You'll notice that, unlike Onshape, FreeCAD directly suggests a dimension from the origin. Still using the Dimension tool, give a vertical dimension of 8 millimeters. Now, all that's left is to delete the large arc to have only one contour. Even though in some cases FreeCAD can handle multiple contours, it's always better to have just one. To delete the arc, simply select the Trim tool in the top menu. Then click on the part of the arc you want to remove. You should now have a fully constrained and completely green sketch. You can click the Close button in the Task menu to exit the sketch. Now, we're going to turn this sketch into a solid by performing an extrusion. In FreeCAD, this operation is called a pad. To do this, make sure Sketch is selected. Then click on the pad icon in the top menu. In the menu that opens, change the length to 14 millimeters to get the correct extrusion height. Then click OK or press Enter to confirm the operation. We should now have the same object in both Onshape and FreeCAD. After this first step, what can we say about Onshape and FreeCAD? Initially, the workflow between the two software is identical. They have the same tools for drawing sketches, the same constraint and modification tools. However, there are a few differences to note. Onshape has better support for sketches with multiple contours, whereas FreeCAD can manage it under certain conditions. Onshape doesn't offer the option to align the view directly perpendicular to the plane, unlike FreeCAD, which provides this option that can be disabled. Additionally, Onshape requires an extra click before entering a dimension, whereas FreeCAD doesn't. Also, FreeCAD automatically proposes creating a dimension from the origin, whereas Onshape does not. For this first step, there isn't much more to say in terms of notable differences. We will now move on to the second step, which involves removing material from the rear part of the clamp. Let's start with Onshape. We will create a sketch on the top face of the clamp. To do this, click on the face, then click on the sketch icon in the top menu. Align the view perpendicularly by clicking on the top icon in the navigation cube. We will start by drawing a center line that will serve as the axis of symmetry. Click on the Line tool, then draw a horizontal line starting from the origin and extending to the midpoint of the left edge. You will notice that Onshape automatically offers to snap to the edge. Press Escape to stop using the tool. To prevent the line from interfering with our sketch, we will convert it into a construction line. To do this, select the line, then go to the Drawing Tools and choose Construction. Next, select the Corner Rectangle tool from the Drawing Tools menu. Draw your rectangle by snapping to the left edge, then finish the last corner by snapping to the edge of the circle. Press Escape to stop using the tool. We will now make this rectangle symmetric with respect to the dashed axis. To do this, select the top left point, then the axis, then the bottom left point, and click on the Symmetry Constraint tool in the top menu. The only thing left is to set a dimension for the width of the rectangle. To do this, click on the Dimension tool in the top menu and set the rectangle's width to 5 millimeters. The sketch is now complete. We can exit it by clicking on the green check mark in the top menu. We will now create the cutout. First, select Sketch 2, then click on the Extrude icon in the top menu. In the menu that opens, select Remove instead of Add and change Blind to Through All. This creates a cut that goes all the way through the part. You can click on the green check mark to confirm the operation. We have finished the cut in Onshape. Now let's look at the procedure in FreeCAD. Start by selecting the top face of the clamp, then click on the sketch icon in the top menu. Unlike Onshape, we don't have direct access to the edges of solids in FreeCAD. We need to project them into the sketch. To do this, click on the Create External Projection Geometry tool in the top menu. Next, select the left edge and the circle. Right-click or press Escape to stop using the tool. Next, select the newly projected lines and convert them into construction lines by clicking on the construction line icon in the top menu. Then, use the rectangle tool and draw a rectangle by placing the first corner on the left edge and the other corner on the circle. Right-click or press Escape to stop using the tool. We will now make the rectangle symmetric with respect to the red axis. To do this, simply select the top right point, then the axis, followed by the bottom right point, and click on the Symmetry Constraint tool in the top menu. The only thing left is to set a dimension for the width of the rectangle. Select the Dimension tool and set the rectangle's width to 5 millimeters. The sketch is fully constrained. We can close it by clicking on the Close icon in the task menu. To create the cutout, we need to select Sketch 001 and then click on the pocket icon in the top menu. Next, change the type to Through All and click OK or press Enter to confirm the operation. We've completed the second step. Now, let's review the differences between the two software programs. We can say that the workflows are quite similar. However, a big advantage goes to Onshape for its ability to snap geometry directly onto existing solids without needing a projection tool. This is a significant time saver and makes the workflow more intuitive. Another notable difference is that Onshape uses the same tool for both adding and removing material. While this requires one extra click compared to FreeCAD, it simplifies the user interface by reducing the number of tools needed. We will now proceed to the third step, creating a slightly more complex and technical opening to see how the software handles it. Let's start with Onshape. The goal of this material removal is to create a small lip at the top of the clamp to prevent it from sliding down the seat tube. We want to ensure a lip thickness of 0.5 millimeters, even if the clamp height changes. The objective is to achieve this without using variables. To begin, flip the part over, select the bottom face to sketch on, then click on the Sketch tool. Using the Circle tool, draw a circle centered at the origin with a diameter of 34.9 millimeters, which corresponds to the diameter of a bicycle seat tube. Click on the green check mark to close the sketch. Next, select Sketch 3 and click on the Extrude tool. Next, select Remove instead of Add in the Extrude options. And in the drop-down menu, choose Up to Face instead of Blind. In the viewport, select the top face of the clamp. We want this extrusion to stop 0.5 millimeters before the top face. In the Extrude menu, check the Offset Distance box and enter a value of 0.5 millimeters. You should see in the 3D preview that the lip has been created properly. This technique ensures a constant gap of 0.5 millimeters, regardless of the clamp's height, even if we were to change it later. Let's see how this operation works in FreeCAD. Turn the clamp around and select the bottom face. Then click on the Create a Sketch icon. Using the Circle tool, draw a circle with a diameter of 34.9 millimeters at the origin of the axis. And click the Close button to exit the sketch. Make sure that Sketch 002 is selected. Then click on the pocket icon in the top menu. In the drop-down menu for Type, change the dimension to Up to Face, then select the top face in the viewport. And change the offset to face to 0.5 millimeters. Then click OK or press Enter to confirm the operation. For this operation, we can note that there are no significant differences. FreeCAD might require 1 or 2 fewer clicks, but the workflow is essentially the same. We will now create 2 5mm fillets on the rear part of the clamp. I noticed that some of you were triggered by the pronunciation of fillet. The correct pronunciation is fillet, with the T pronounced, and I'll make an effort to use this pronunciation for the rest of the video. Let's start with Onshape. Select the 2 rear edges of the clamp and click on the fillet tool in the top menu. Change the radius to a value of 5mm. Before confirming the operation, I like to point out that in Onshape, you can set a fillet radius larger than the available width, and the operation will still succeed. Try setting it to 10mm, you'll see that it works. In our case, keep it at 5mm, then click the green check mark at the top. Let's now see how this works in FreeCAD. Select the 2 rear edges of the clamp, then click on the fillet tool in the top menu. Set the radius to 5mm. If you try to set a radius of 10mm, you'll see that the operation won't succeed, unlike in Onshape where the operation works. You'll need to find another technique if you want to create a larger fillet. Press Enter or click the OK button to accept the operation. For this fillet operation, we can note that once again, the workflow is the same. It's not easier in either case. The biggest difference lies in the flexibility to create radii larger than the available length with Onshape. In FreeCAD, this operation is not possible and requires finding a workaround or another way of modeling to achieve the desired shape. Let's now focus on creating custom planes, starting with Onshape. We will now create the hole at the back of the clamp to insert the bolt. We could do this using a hole operation, but I think it's more relevant here to perform 2 material removal operations instead. Select the face on the inside of the back part of the clamp, and then click on the Sketch tool to create a sketch at that location. The goal is to create a circle at the center of this face. To do this, using the Line tool, we will first draw a vertical line starting from the center of the bottom edge and ending at the top edge. Next, select the line and convert it into a construction line. Next, use the Circle tool to draw a 5mm diameter circle at the center of the line you just created. If the circle is in construction mode, convert it back to a solid line using the same tool. You can exit the sketch by clicking the green check mark. Next, select Sketch 4, then click on the Extrude tool and perform a remove through all. Also, check the symmetric box so that the operation is performed in both directions. Click the check mark to confirm the operation. So far, nothing new under the sun. Let's do the same operation in FreeCAD before creating the custom plane. Select the face on the inside of the back part of the clamp, and then click on the Sketch tool to create a sketch at that location. In FreeCAD, you can have a section view while drawing your sketch. To do this, simply click on the icon in the menu bar. This allows you to see exactly where your sketch will be drawn. Unlike Onshape, we need to project the edges to be able to snap onto them. Using the External Geometry tool, click on both edges to project them into the sketch, and convert them into construction lines to prevent them from interfering with the sketch. Then, use the Line tool to create a vertical line starting from the midpoint of the bottom edge. Next, select this line and convert it into a construction line. Using the Circle tool, draw a circle at the center of the line with a diameter of 5mm. Then click on Close to exit the sketch. With Sketch 003 selected, click on the Pocket tool icon, then choose Through All and check Symmetric, and click OK to confirm the operation. We will now create a custom plane to perform a material removal for the bolt head, starting with Onshape. To do this, select an extreme point of the fillet, like this one, and then the interface of the clamp. After that, click on the plane icon in the top menu. The plane has been created exactly at the intended location, so you can confirm the operation. We will now draw a circle on this plane. Select the plane, then click on the sketch icon in the top menu. You can align the view by clicking on the front of the navigation cube. Using the Circle tool, create a circle with a diameter of 8.7mm. You can place it randomly, We will constrain it later. Next, select the whole circle and the newly created circle and apply a concentric constraint. The circle should now be in its correct position. You can exit by clicking the green check mark. Next, select Sketch 5, then click on the Extrude icon in the top menu. Choose Remove, then check Second End Position and enter 4 mm for the first direction and 2 mm for the second direction. Click the green check mark to confirm the operation. You can optionally hide the plane for better visibility. Let's now look at how to create this custom plane in FreeCAD. While holding the Control key, select the end top point of the fillet and the inner face of the clamp. Then click on the Datum Plane Creation tool. The plane should now be created exactly in the correct position. You can confirm by clicking OK. Next, select the datum plane, then click on the Create Sketch icon. Click on the Section View icon, and by using the External Geometry tool, select the circle of the hole. Right-click or press Escape to stop the tool, then convert the circle into a construction line. Using the Circle tool, draw a circle with a diameter of 8.7 mm at the center of the projected circle. Then, click on Close to finish the sketch. You can hide the datum plane for better visibility. With Sketch 004 selected, click on the pocket icon in the top menu. Change the type to 2 dimensions and set the first direction to 4 mm and the second direction to 2 mm. Press Enter or click OK to confirm the operation. You should have the same result in Onshape and FreeCAD. In this case, the workflows for creating a custom plane are identical. To make the part easier to insert onto the seat tube, we'll add a small chamfer on the rounded edge of the bottom face. Starting with Onshape, select the rounded edge of the bottom face, then click on the chamfer icon. Give a value of 1 mm, then confirm. To create a chamfer in FreeCAD, select the edge of the circle on the bottom face, then click on the chamfer icon. Give a value of 1 mm for the chamfer, then click OK to confirm the operation. The process of creating a chamfer is the same in both software. To make the clamp more visually appealing, we'll add a 1 mm fillet to the top and bottom edges. I'll speed up the video 3x since it's the same as the fillet we created earlier, and there is no difference between Onshape and FreeCAD. Let's move on to a small assembly to compare how the two software handle it. We will add an M5 bolt and create an assembly with this bolt. Before starting the assembly, let's rename the two bodies to clamp to have a proper file structure. Let's start the assembly with Onshape. You need to switch to the Assembly workspace by clicking on the Assembly tab at the bottom left of the screen. Start by inserting the clamp into the assembly. To do this, click on the Insert icon and select the clamp body. Since we're not cavemen, we'll generate the M5 bolt directly at the right location in the assembly. To do this, click on Insert again. Go to the Standard Content tab. As I did before, Onshape has kept my last bolt generation. Onshape gives you the option to generate various types of fasteners according to their different standards, categories, and classes. In our case, we select ISO, bolt and screws, socket head screw, then hex socket ISO 4762 with a size of M5 and a length of 20. To create your bolt afterwards, nothing could be simpler. Just click on the Insert icon at the bottom. Onshape generates the bolt, and you can directly place it on your clamp by selecting the inner edge of the clamp. It's a very fast way to add fasteners to your assembly, as it automatically applies the constraint between the clamp and the bolt. Let's now see how to do this with FreeCAD. First, you need to download the Fastener Workbench by going to Tools and then Add in Manager. Once downloaded, go to the Workbench drop-down menu and choose Fasteners. This workbench has a vast selection of fasteners that you can use for your projects. You can place bolts directly in this workbench, but we will use the Assembly Workbench to join the clamp and the screw together to ensure that the bolt's position updates along with the clamp. click on the ISO 4762 bolt from menu. You can see that the bolt has been created in the tree view. To change its properties, select the bolt and in the Properties panel, change the diameter to M5 and the length to 20 millimeters. The bolt should update and be positioned at the center of the clamp. To continue with the assembly in FreeCAD, switch to the Assembly Workbench, which has been added since version 1.0 of FreeCAD. To create an assembly, click on the Create Assembly icon in the top menu. Before continuing with the assembly, you need to hide the clamp and the bolt by clicking on the eye icon in the tree view. Then, click on the Insert Component icon in the top menu to import the parts. Start by clicking on Clamp to import this part first. FreeCAD will automatically ask if this part should be fixed. Click Yes in the menu that appears. Next, import the M5 bolt by clicking on it. You can use the Parts gizmo to move the bolt and place it in a more accessible position. And click OK to confirm the insertion. We will now create a joint between the bolt and the clamp. To do this, select the edge of the bolt that will be in contact with the clamp. Then select the corresponding edge on the clamp while holding the Control key. Then click on the Fix Joint icon in the Assembly Tools menu. The bolt should now be correctly positioned on the clamp. You can click OK to confirm. Our two assemblies are now complete. What can we take away from this experience? The assembly technique is the same between both software. However, we can note that in Onshape, adding fasteners is greatly simplified since we can assemble them directly. FreeCAD's fastener library is more extensive, but it requires installing an add-on, which is free. A small detail, FreeCAD asks to fix a part at the beginning of the assembly to ensure the components don't move, unlike Onshape. It's also worth mentioning that FreeCAD's assembly workbench is still less stable compared to Onshape's. So, what can we conclude after this modeling and assembly test? In summary, Onshape offers a smoother and more optimized workflow, while FreeCAD provides greater flexibility with more customizable tools, but the cost of sometimes more technical manipulation. But we must consider two important factors: price and accessibility. On one hand, Onshape is a paid software costing around $1,500 for the license, or it could be free, but with a big asterisk. Your files must be public, and you can't use the software to create pieces for sale. You also need an internet connection to model and access your files. FreeCAD is the complete opposite. The software is free and open source. You don't need an internet connection, and your files are private. Let me know in the comments what you think about this and which software you use and why. I think there's never been a better time to test FreeCAD because, as we've seen, the workflow is the same as that of paid CAD softwares. If you want to learn FreeCAD, you can subscribe to my channel, where you'll find several tutorials showing you how to use FreeCAD professionally. I hope you learned something from this video or that it entertained you. Thank you for your attention.